Welcome to the first lecture on the introduction to the data science and artificial intelligence class. Today we will be not talking a lot about DA. This is the first class, right? But the gate is also coming up very shortly. But we'll still try to cover as much as possible for you to better understand things and all. I hope you guys still know about a bit about DA. If you don't, then it's okay. Um, just make sure there's a lot of overlap between the computer science syllabus and the DA syllabus. So we will first be doing a syllabus review of what we have to explicitly study, because there are many topics that we have already studied in computer science, and we will do just a one small practice question on each of the topics today, just to check whether you are ready with at least the part that is known to you, right? And then we will talk a bit about data science. We'll talk about very small concepts, very important concepts as far the exam is concerned. I will talk them through some analogies, the mathematical details and everything, whatever is the maths behind every algorithm of machine learning. So I will be taking your machine learning classes. We'll start from the next class, but today we'll be doing more of a syllabus review, a bit more about how the gate DA is structured around things and how you can also excel in the same. So let's begin. As always, for people who might not know me by now, I am Aditya Agrawal, your instructor. I hold an MS in computer science from IIT Madras. I was an ex-data scientist working in high radius technologies here in Hyderabad, and I hold a BTech in computer science from KIIT University. So today's lecture will be more on introduction, as I said, starting with syllabus review. So I will quickly go through the syllabus. I hope you have gone through the syllabus by now. I mean, most of you might have gone through, because come on, the first thing you do before preparing an exam is to find out the syllabus. So first subject that you have is probability and statistics. You have these many topics. And if you notice very clearly, there are some words that are labeled green. Do you want to guess what this mean? What does it mean when the label is green, the words labeled green? What are those? Any guesses? They are in the CS paper as well. Well done. Very good. So if you look at the words labeled like counting, like Bayes theorem, like variance, mean, mode, standard deviation, correlation, covariance, and the likes like probability distributions, Poisson, and all that, they are also part of your computer science paper as well. Some other things are also there. They are not explicitly mentioned in the CS syllabus. For example, any beginner trying to learn probability would probably want to know what is the sample space and events. But I have not written it here because they are not actually added as part of the syllabus. But some words that are exactly the same that have been highlighted here. So, and each time when I discuss a syllabus review, we will do a very small practice question of each syllabus from the part where it is available in the gate, and also if that can be useful for the ML DA paper as well. One of the crucial aspects of this subject is you need to be very thorough with something called Bayes theorem. I hope you guys know what is Bayes theorem. Okay, how to find the probability using Bayes theorem. Bayes theorem, there is an ML algorithm associated with this entire theorem, which is called naive Bayes algorithm. So if you know Bayes theorem, then consider yourself that with just some modifications to the Bayes theorem, you have covered one ML algorithm as well. Okay, but I'm not saying other topics aren't important. They are as well, because this is the first time DA paper has been introduced, so you never know what will be asked. But my hunch is they will ask a lot of questions from Bayes theorem in this subject. Okay, so make sure you are well aware of it, and also make sure you are well aware of the normal distribution and the standard normal distribution. What is the equation? How do you standardize it, and the likes of it? And also one thing that is only exclusive is central limit theorem. Very important theorem when it comes to data science. Okay, but please make sure you are aware of these all of these as well, because probability and statistics form the core. So this is the small practice question that I would want to say ask you guys, so that we are up on track, right? So if you need a minute to solve it, please go ahead, or else I will solve it. That's okay. Else I would say better would be if we solve it together. Okay. So what are the events in this question? One is an event F, right? Maybe I will use a different color to denote the event. Let's say there is an event F which says that child has flu. And what is the probability that the event F has occurred? It is 0.9, because 90%. There is another event that child has measles. And what is the probability that the child has measles? It is 0.1. Anything else? Is there any conditional probability given in the question? See, I assume you guys know this, okay? If you don't, then let me know. I can teach this, okay? So there are two conditional probabilities given in the question, and why I am saying conditional probability is, see, read this line. The probability of observing rashes for measles is 0.95, which means given that a person has, or a child has measles, it is given that the person has measles, the probability that it has a rash is nothing but 0.95. Understood? And the probability that given the person has flu, the probability that he will develop a rash or observe a rash is 0.08. Okay, fine. And now you need to find out that given that a child has developed rashes, see, if a child developed rashes, find the child's probability of having a flu. Okay. So, what is the conditional probability formula? Do you know what is the formula for this one? If you want to calculate the probability that you are having flu, given that you develop a rash, is nothing but what is the probability that you are having flu and rash divided by what is the probability that you are having rash. Very simple conditional formula, conditional probability formula. I have not done any Bayes theorem till now. But by Bayes theorem, what you can do is, so P of A intersection B is nothing but P of P of A multiplied by P of P intersection A. It is also P of B multiplied by P of A given B. Okay. So one trick that I can tell you whether you should use the first formula or the second is flip the two conditions. Given F, given R, you will write this as P of R given F. And whatever is in the denominator, you multiply the probability with that. Understood what I'm saying? P of F given R, you flip it. P of R given F. And what is in the denominator, or it's not exactly denominator, but given in this case it's flu, we just multiply the probability of flu with it. Divided by, now how do you calculate the P of R? Given the information. How can you calculate P of R? See, the question says you will have rashes only if you have measles, only if you have flu. Two events are possible, right? In the given question. So, the probability that you will develop a rash given you have flu multiplied by the probability of flu, or it could be the case that you will develop a rash given that you have measles multiplied by what is the probability that you are actually having measles. Understood from where it comes? Don't just mug up the formula. I will repeat this formula again. So, rashes either you can develop if you have measles or if you have flu. What is the probability that you will develop rashes given you have flu multiplied by what is the probability actually that you have flu? It could be one case, or what is the probability that you are having rashes given you have measles multiplied by the probability of having measles. And now if you plug in the formula and the values, you have 0.95 multiplied by 0.9 divided by 0.95 multiplied by 0.9 plus 0.0. Did I do something wrong here? Okay. So probability of R given F is 0.08, it's not 0.95. That's what I've done, mistake. And then the other one is 0.95 multiplied by probability of measles is 0.1. And whatever you get will be your answer. I'm not calculating this answer, but more of how to solve it. Understood? Good. Now the next one is, yeah. So the next one is a question on statistics. Just to check your understanding, okay? You might not know anything now, but still, just apply some brains. That's it. So let's say there is a data set of two columns X and Y. Okay, two columns X and Y. These are the observations. When X is 1, Y is 10. When X is 2, Y is 30. When X is 3, Y is 40. But if you look carefully, from wherever data you have collected, whichever source you have collected it from, the data point for X equal to 4 is missing. There is no Y. And when you are a data scientist, the first of the many things that you will also do is to fill in missing values, in which case you would want to fill an appropriate value at this location. Okay, given this data set, what value will you fill here? Just apply your brain, nothing else. I don't want to bog down with anything here. Okay, what can you do? You could be wrong. As I say, today we are only discussing things. Okay, but still you will learn a concept today. So don't worry about that. What will you do? Average of the remaining value. Very good. Perfect. Perfect. You will do the average of the remaining value, or let's say mean, right? If you do the mean, what is the mean of this data set? 10 plus 30 plus 40 plus 70 plus 80 plus 3000 plus 55 divided by how much will it be? I guess so 37, right? 3230 3285 by 7, which is 469 point something. Okay. So you will fill here 469 point something. Is it the best case that you can do? Is it the best you can do? Let's say I am arguing with you. I am taking your data science interview and I am your manager. Let's say I am arguing with you saying the values are all centered around 10, 20, 30, 40, 70, 80, 50, but this is 469. So this is not a very candidate value that you can replace it with. What else can you do? Very good, perfect. What you can do here is something called median. And if you take the median, if you calculate the median, what will be the median of this data set? 10, 30, 40, 55, 70, 80, 3000. So you arrange the data in a sorted order and then you take the middle value. In this case, 55. So you will say that the value, if I consider median, is 55. Correct? This is what you will do. Anything else you can do. Here, can you do something called a mode? Do you know what is a mode? MODE. So there is another thing called a mode, which means which data point occurs the most number of times. If you look at here carefully, each data point occurs only once. So there is no mode. Okay, there is no mode actually in this data set because there is not a single data point that occurs more than once. Every data point occurs only once only. You cannot declaratively say whoever is a mode. So mode is also not the right way. But if I ask you this question, again, I am your data science interviewer, let's say, why did mean give such a huge value and median gave only this? What is the reason? Median value depends on at most two values. The other thing that you can say here is that 3000 is actually an outlier. There is a concept in data science called an outlier. Outlier means one of the values is very off compared to the stream of values. So in this case, whatever is the stream of values, which is 10, it's between 10 to 80. And there is one value that is very off from this range, which is like 3000, right? So that is why, and when you calculate the mean, you have to use the outlier. So mean is susceptible to outliers. That is why in mean, since you are considering the outlier value as well, you will get the value as a huge value, which is not a good representative of the central tendency. But if you consider median, it would be better. This question, actually, I will tell you, was asked to me in my Amazon interview long back in 2019. I had interviewed in Amazon as a data scientist, data science engineer. They had asked me this same question they had asked me. Okay. So this is not a question that I created on my own. This was asked by my interviewer only. Okay. So the first thing that you will actually do is you will use the measure of central tendency, mean median mode. We already calculated the mean median mode. And now we come to the another next subject, that is another important subject for TA, okay, which is linear algebra. And as you can see, this subject does not have much overlap with the computer science syllabus, which also means that more focus has to be given on this subject. Okay, matrices, orthogonal matrix, idempotent matrix, eigenvalue and eigenvector, how to calculate a determinant of a matrix, how to calculate the rank of a matrix, LU decomposition form as one part. If you know LU decomposition, then SVD or singular value decomposition is also not very difficult. My prediction, there will be a lot of questions on SVD in the exam. And why, if you ask? Because there is a concept called LCA. Okay. Oh, sorry, PCA. PCA is in data science, data structure. PCA, principal component analysis, where you will use some part of SVD only to gauge the values. And the other important thing is systems of linear equations and solutions. I think this is also there in GATE. I mistakenly have not marked it, I guess, because I myself remember I studied this. So Aditya, can you confirm if this is there in the syllabus as well? Systems of linear equations and solutions. I think so. It is. So this is one other thing that is there, and my hunch is this will also have a lot of questions because entire linear regression is based on this topic only. Okay, fine. So one question based on what we have learned is this: what is the rank of this matrix? Okay, two. Okay, okay. Yeah, the answer is two only. Let's solve it. Use a different color for solving. So this is the matrix figure, right? 5, 1, 3, 10, 10, 0, 2, 6, 6. The first step, as always, um, is to convert this matrix into something called a row echelon. Many people say something, but I say echelon form, row echelon form, right? And how will you convert it? What is the first step? So maybe what I will do is I will interchange R1 and R2, right? So I have 1, 0, 2, 5, 10, 10, 3, 6, 6. Then I will use something called a pivot. In this case, then I will use something called a pivot. In this case is this one, right? Correct, correct, correct. Very good, Aditya. So what I will do is I will use this first element as a pivot, and to make this element as 0, which is A21, I will do R2 minus 5 of R1, and R3 is R3 minus 3 of R1, so that I can turn this 3 also to 0. So if I do that, I get the same first row as it is because I have not changed anything. Second row becomes 0. This is 10. This is 0 because 10 minus 2 into 5. Third row, this is 0. This is 6. And this is 0. Right? Okay. Next step, what do I do? I can make this value as 0, taking the next one as pivot. This is 0. So I can take this one as a pivot. And can I turn 6 into 0? I think I can, which is if I do R3 minus 6 by 10 of R2, then what I get is I get something called 1, 0, 2, 0, 10, 0, and then 0, 0, 0. Now, when you cannot go any further, which in the sense you took from the first row non-zero value, which is 1 in this case, as a pivot. Second row you took 10 as a pivot. In the third row all are zeros, you cannot take anything as a pivot, and then you reach the end of the matrix. You count the number of non-zero rows, which means how many rows are there in the matrix that have non-zero entries. Correct? So if you look at it, first row has a non-zero entry and the second row has a non-zero entry. The third row is all zeros, so that doesn't count. So that's why the rank of this matrix is 2. Okay. Convert to row echelon form and then count the non-zero rows. Okay. Then we come to another syllabus that we talk about, which is calculus and optimizations. I hope you guys know about this very well by now. Functions of a single variable, limit, continuity, and differentiability, maxima and minima, optimizations involving a singular variable. I am not pretty sure about which topic is most important here because this is not something that is very important as per the exam, but this topic is also very scoring, right? It's very simple. Okay, if you are starting to know this, very simple. So I would say maxima, minima, and limit won't take much of your time. So make sure you are well aware of these two. If you are not, continuity and differentiability is also something very simple, guys. It's not very difficult. There's some set of rules. You find the limit. If the limit equals the functional value at that point, then it is continuous. Differentiability, I might have forgotten now, but there was something related to differentiability as well. Some simple formula is there. So don't skip it. It's very simple. Okay. And functions of a single variable, you might think, where is it there? It is there in discrete mathematics, if you don't recall. Taylor series, okay, you can do it, it's fine. Optimizations involving a single variable also is one topic that is there. That I think it's important, but still, I don't believe these are as important as what we learned in the earlier subjects. So make sure you are more thorough with them. But still, whatever we have in the gate, this is the question. Yeah, something very simple. Okay. So the biggest mistake that students tend to make when solving limits is they are aware of a rule called L hospital rule. People call it L hospital, some call it Lapita. The name doesn't matter, the method matters. I call it L hospital rule. So many people have this tendency that they want to use something called the L hospital rule right away, which is the biggest mistake that people do. L hospital rule, if you don't know, you can use it on only two scenarios. If your expression is a 0 by 0 form, or it's an infinity by infinity form called an indeterminate form. Very good. So please make sure you are first checking that, and then maybe you can use that formula. So if you look carefully, if you plug in the value 2 in this expression, you will get a 0 by 0 indeterminate form. So you can use L'Hospital rule. And if you don't know differentiation, if you have forgotten it, please go and revise it. Okay. So it's just the tricky part here is what is the differentiation of root x, right? Which is nothing but 1 by 2 root x. Okay. How does this come up? Again, please revise, guys. I hope you know this. You are here because of some reason. In your college, school also you have learned it, but still. So if you apply this rule, limit x tends to 2, d dx of root x minus root 2 divided by d dx of x minus 2, this will be nothing but 1 by 2 root x. Because, why? Because ddx of x is 1 and ddx of any constant is 0. If you plug in the value of the limit to this expression, you get the answer as 1 by 2 root 2. That is also one way you can think of it. Very good. Okay. Okay. Denominator is in the a square minus b square form as well. So root x plus root 2, root x minus root 2. Very good. 1 by root x plus 2, and then you can plug in the value as well. Good. So this is nothing but 1 by 2 root 2, which is the options. So again, we are just trying to read the syllabus and do some questions that were asked in GATE to give you all confidence. The next topic is a very, very important topic, and the greens might give you a lot of things, lot of happiness that finally there is one topic that I actually know, which is programming data structure and algorithms. Basic data structures like stacks, queues, linked list trees, hash tables, search algorithms like linear search, binary search, sorting algorithms, divide and conquer method, introduction to graph theory, basic graph algorithms. See, this is the most important topic in GATE CS only. Okay, so if you are not studied this subject, then there's not a point to give the GATE exam. I will be very honest. Okay, so I won't say which is important and which is not, because this is a topic that you should know if you are studying the GATE. Programming in Python. You guys are C experts. Okay, so Python is not a very difficult language to learn, considering you know C. Okay, just I will give you one small tip when learning Python. Don't focus on learning libraries. There's no point. Learn how to do basic Python programming. For instance, how you can use dictionaries. What is the difference between a tuple and dictionary? Okay, this maybe they can ask one question. What is the difference between a tuple and a dictionary? And there could be some questions like on list comprehension. So please learn list comprehension because that is a very important topic in this exam. Okay? List comprehensions. No, you don't have oops. This is from the exact GATE syllabus. Okay, you do not have object-oriented programming. Okay. Okay, you are saying programming in Python. I don't see they will ask it because it's not very important, but they have not mentioned anything. So, see, I won't say don't ignore oops. Maybe you can study oops, but Don't go too much into detail like we have in Java or C++. Okay. Just learn basically how you can make a class in Python. And there is something called self object in Python. Bus, nothing else. Self and class. Basic how to just make a class and self. That's it. Okay, no need to go into details like polymorphism and all that. Even if it is there in the syllabus, you don't have time to read it, but focus more on list comprehensions and some integrate details of Python like tuples and dictionaries. Okay, and then you should be okay. So, one small practice question is this. Solving or don't know how to solve. Okay, I'll give you 1 minute then. Okay, time's up. Answer D. Okay, let's see. So there are two things that you need to solve this question. One is pre-order. How do you traverse a tree in pre-order? Which is root followed by left subtree followed by right subtree. And the second property you need to know is the BST property. Which means if I have a node n all values lesser than n will be here, and all the values greater than n will be here. The answer. Fine. So a pre-order says that you first traverse the route. So you first traverse the route, and then you know now that the root of the tree is 30. And then you go left. So you come to 20, which is the root of the left subtree. Then again you go left. Okay. And then, so root left, then you again go left. Now there should not be any left subtree of this of 10. Why? Because if there would have been, then you would have gone to the left and the value would have been smaller. But here if you see, the next value is 15, which means it is the right subtree. Okay. So you go up, and then you reach 20. So you process the right subtree, which is 25. Now 25, when you go to the left, you get 23. And then it's 39, so you have to go to the root. Then you go left, then you go right. And what will be the post-order traversal now? Post-order traversal is left-right root. So if you go left, there's a subtree rooted at 20. You go left, there is a subtree rooted at 10. You go left, there is nothing. You go right, there is 15. And then you reach the root. Then you go right, you go left, right, root. Okay. Then you get 35, 42, 39, 30. Okay. So which option matches? D, I think, would match. Yes. So this is one of the most important question to be asked in the exams. Any GATE CS also, not just GATE DA. So make sure you are aware of it. The last subject that has some overlap with the CS syllabus is this one, database management and warehousing. This also has some new topics present, which is data types, discretization, sampling, compression, data warehouse modeling, schema for multidimensional data models, concept hierarchies, measures, categories, and computations, while others are there also in your GATE syllabus, CS syllabus, model, relational algebra, tuple calculus, SQL, integrity constraints, normal form, file organization, indexing, and data transformation such as normalization. Normalization, please make sure you are well aware of it. Normalization is also very important for your GATE CS. 1NF, 2NF, 3NF, BCNF. Okay. So make sure you are well aware of it. So we'll solve an SQL question as part of this, because for the GATE DA part, I believe, again, my hunch, there will be a lot of questions from SQL. Because if you work as a data scientist in any of the companies, the first thing you have to do is get the data from somewhere, right? So how would you query the data from the relational model, which is SQL? So the level of complexity of SQL in GATE CS will be lesser than GATE DA, because in GATE DA it's everything about SQL. Okay, and normalization is always important here, and make sure you are well aware of things like this. Okay, fine. So let's do the SQL question. Try this out. I will give a minute. Okay, so uh, so one trick that I can again tell you how to solve SQL questions is always make sure that um, you solve the inner queries first if they are if you can. Okay, why I say if you can, because if they are dependent, then obviously you cannot. But if you can solve it somehow, if you get a rough idea of how the inner query works, then please go ahead and then look at the outer query. So I see there is an inner query here, which is you select the average salary from the employee table. Irrespective of any department or anything, this selects the average salary of all employees. Done. Now read the query. You select the department ID and count the number of such from the employee, where you get the gender as female, which means you're only counting the female employees, and their salary should be greater than the average salary of all employees in the department. So now what is the question? The above query returns for each department the number of female workers whose salary is higher than the company's average salary of all employees in the company. Okay, once you solve the inner query, then it's just reading the question. Okay, fine. Any questions regarding database management systems, warehousing, anything you want to ask regarding the syllabus? Okay, good. Now, two subjects that are important, but that are absolutely new, right? One is, as always, the heart of data science, which is machine learning. Um, I will be taking this course of yours. Um, there are a lot of topics that have to be covered. Not sure in the given time period how much we will try to cover. What I will focus more on is trying to learn. If we learn lesser topics and if we learn in greater depth those topics, so that you can answer any questions, that is much more than looking at all the topics in a breadth first manner. That way you won't be able to solve any question. So but still I will try to finish as much as possible before the exam. I mean, we will give you some time to prepare as well, so uh, the classes won't be till the last day of the exam, so don't worry about that. But still, this is a topic that is actually the heart of this entire course. So if they don't ask any questions on this topic, then there is no point to sit in this exam also, because this is the most important topic for the entire GATE DA exam. Okay. So make sure we'll study this topic. Don't worry about it. Okay. We will study with analogy so that you tend to remember things in a better manner. Okay. Mathematically also we'll have to look at things. There's no options, but still I will try to make it as fun as possible for you guys. Okay, and the last topic is AI, which is artificial intelligence. This is more like agent and how it involves with the environment and all. I don't actually know why they give this in the exam, because this is something fine. Okay, I don't want to argue with anyone, but still, this is more looks like just something to finish the syllabus. Okay, this is also a good course. There's not much topics here. Um, This is also very simple. Not these are not very difficult topics, whatever is given in the question. Okay. So we'll see how we can handle it. Okay. So this was the syllabus review, and let's start with some data science today. Okay. Now, before starting, if anyone has any questions, maybe you can take that. Then we can go ahead. Okay. Okay. So look at this data set. Okay. Um, this denotes the marks secured by me or Aditya across different years of GATE. Okay. GATE 2015, I scored 10 marks. GATE 2016, I scored 20. 17, I scored 30. 18, I scored 40. 19, I scored 50. 20, I scored 60. 21, 70, 80, 90. Just by looking at this data, can you answer me a very basic question? Can you tell me how much marks will Aditya score in 2024? Why? So I got an answer as 100. Okay. First, I would like to thank that person because they have given me full marks in GATE. Thank you very much. But still, why do you think it will be 100? Why not any other number? So, good. So you are saying every year there is an increase of 10 marks, which means what? From looking at the data, you are trying to find something called a pattern. I didn't tell you how much marks will I score. I didn't even tell you that how is my preparation going ahead. I didn't even tell you that how is Aditya practicing. I didn't even tell you anything. I just gave you this data. That's it. Okay. And then looking at this data, you say in 2024 I will get 100 marks. Okay. Fine. So typically, what humans think is like we tend to think very fast, but how computers would think of it this way. So what I drew, what I talked about earlier, the data set, I have drawn something called a very simple scatter plot, meaning just XY set of XY axis and some points. And the X axis denotes the year, while the Y axis denotes the marks that I've secured. And if you look very clearly here, you can see a steady jump in the marks. Programmatically, programmatically, how will you design this algorithm? So you said in 2024, I will get 100. Correct? Let's say I gave you data only till this point. Which is, I gave you data till 2020. And I asked you how much marks will Aditya score in 2021. Okay. How will you tell the computer to solve it? What will you do? You discovered a pattern. You told me every year there is an increase of 10 marks. What else? So, have you heard of a concept called the equation of a straight line? So, let's say I offset each year, which is instead of writing at 2015, I write as 1. This is the second. This is 3. This is 4. This is 5, and so on. And this is right. So I can write this as a very simple equation y equal to 10x. Yes or no? The first year I get 10 marks. Second year I get 20 marks. Third year I get 30 marks. This is the perfect way to explain the perfect way to find a function. So now if I tell you how much marks will I secure in the seventh year, you have this. Can you code this in Python or C? Is this not very difficult? Isn't this very easy to code in C? So int y, int x, return x into 10. Done. C programming, right? So if I input 7 to this function, what it will output me? It will give me 70. If I input the value 8, what it will give me? 80. Correct? This is actually what is machine learning. which means I have a slide later on as well. Given your data set, can you find out a function which we call a hypothesis? Given the data set, can you find out a hypothesis? This could be h of x, such that with this h of x, you can use it to predict the future outcome. Which in this case, if you're sorry, yeah, not zoomed in. Okay, fine. It's zoomed out as well. So if you can find out this hypothesis, then you can use it to do future predictions. Okay. So one of the ways to find out, there are different algorithms that exist to find out the perfect, best function, and that's how you will be able to do it. There are many subtleties to it as well. We'll discuss those today. Okay, your concepts will be very clear today. But basically, the funda of machine learning is you have data, you put it to a model, you create something called a hypothesis function that you can use to do predictions. Okay. Right. So again, as I said, this is a line you might fit, and then that's how you can get the correct value. Is the data always so well presented? In the sense, the data earlier was like you were every year getting 10 marks increase. Is that always the case? Like, is data so easy to predict always? In the real world scenario? No, right? For example, look at this example. This is the month of 2023, the first month, second month, third month. And the y-axis or the second column denotes, so this is your y-axis, this is your x-axis, denotes how much hours you studied per day on an average. If you look very carefully, initially in the first month of 2023, you might think gate is long ahead, no point of studying 5-6 hours a day. You studied 1 hour per day on average, even one is more, but one, just consider a typical scenario. As and when you reach the gate deadline, you start studying 18 hours a day on average. If I ask you how many hours a day on average will you study on the 12th month? By looking at this example, this might seem not very counterintuitive to answer because this is not something very linear relationship here. It's sometimes you're studying 2, 4, 7, 14, and 18. First thing that you might think of is let's draw a graph. This is your graph. Okay. Now, if I am a very beginner machine learning guy, I will say let's draw this straight line. Okay. That forms my hypothesis. Is this a good hypothesis? Is this a good hypothesis? In the sense, am I able to fit the model perfectly? Which means, if you look at month 4, in actual, I was studying 2 hours a day on average. But if you try to look at the graph, the model will say that you have actually studied 6 hours a day on average. Yes or no? So is this a good model? Can I do something better? Can I do something better? Let me give you a hint. Have you heard of polynomials? So what can we do? Can we fit a curve? Will that be better? In the sense, can I do something like So just a minute. Let me use a different color so that there's no confusion. Can I do something like this? Which one is a better hypothesis according to you? The green one or the black one? If you look carefully, the green one might sound a better one because you are fitting the data in a better manner, in a more efficient manner. Okay. And if you look at the graph carefully as well, if you look very carefully, right, there is something like you are not actually, you are going exponential. See, initially you were studying for only one, then you thought, okay, I will double it, then I will double it, then maybe somewhat doubling it because it's four, you went from 4 to 7. Then you thought, okay, let's increment to 10. Then you thought, okay, let's increment to 14. Then you went 18. So there is some form of an exponential relationship in this graph. Now, the main crux of machine learning algorithms is to try to fit this polynomial or this line. Okay, that is the main crux of any algorithm. Okay, they will find you the best coefficients for the line or the curve that will fit your data. Okay, so again, what did I say earlier? In a traditional computer science program, so this is your traditional CS. What you are doing is you have something called a program that you have made in your C language. You start this program on your computer, you run this program on your computer by giving it some input data, which is the data part, and you expect some output back. Fine. Machine learning is something reverse. In machine learning, you input the data as well as the output. See, earlier when you were trying to draw this plane, draw this line, if I wouldn't have given you y, which is the output, how the heck would you have even told me that there could be a line fitting, right? So that is why, that is the reason why um, you feed the data, which is the x, you feed the output, which is the y, and out comes something called a program. And this thing is nothing but machine learning. Which program to come out, which program will be the best one that explains the data, that is a job of your machine learning algorithm. Even deep learning also works in the similar manner as well. That is not in the syllabus, but just letting you know. So, and collectively, when you give the data as well as the output, feed it to a computer program, it will give you something called a program. And with that program, you can fit in your test data, which is the data you want to test your new algorithm with, new hypothesis with, to give you the output. So this region of machine learning is called your training part, which is which is in the case the program is in the from the earlier example, the program is y equal to 10x, and the data could be anything. Let's say for the 10th year you are calculating, and the output will be 100. So this part is called testing. So usually any machine learning algorithm involves something called a training, which is trying to fit a model given the input data, which is the data and the output. And testing would mean trying to test what the hypothesis given your test data. Okay. And very basic, very simple thing here is when you are trying to test your data, okay, then make sure that your training data does not have any access to your test data. It is more like saying, so I will give you some analogy as well later on, don't worry. Okay. So let's start with an analogy before, okay, maybe I'll give you an analogy now. Let's say you're preparing for the gate exam. Okay, you're preparing for the gate exam, which means you're trying to train a model which will help you to solve the questions of the gate exam. The program is that you want to prepare for the gate exam. Okay, your data and output would be like lectures, maybe PYQs, and so on. You will do all these things to train your model, which is train you to prepare for the gate exam. And when you're trying to go to the exam during testing, your data will be nothing but your gate question paper. Now, if I ask you a very basic question, when you're trying to train your model, which is when you're trying to train your model to give the gate question paper, if I, let's say, give you the gate question paper along with it, that will come next year, how do you think you will perform in the exam? Understood the question? The question is you're trying to prepare for the gate, which means you're trying to train a model, which is you, such that it can take the gate question paper and give you the output, whether it is correct or not. If I tell you that when you're trying to train yourself, which is when you're trying to watch the lectures and do the PYQs, I gave you the next year gate question paper as well, 2024 gate paper as well. How do you think you will perform in the exam? Will you get full marks in that case? Yes or no? No. If I have given you the GATE question paper as well, GATE 2024 paper as well. Now I have given you, let's say. Still no. Obviously, right? So that means during training, you do not have access to the test data, which means you do not have access to the GATE question paper. But what you do is you still look at the existing data, the history data, whatever you have, which is in this case you have your lectures and PYQs, and you use that to learn to read the gate exam and then give the paper in the final day. So now there are two types of machine learning. One is called supervised learning, another is called unsupervised learning. In our lectures till now, whatever data we have seen is that the data set, let's call it capital D, consists of a pair which is x1, y1. Okay, this is one of the example. Another could be x2, y2, x3, y3, so on till xn, yn. N data samples. Okay, x1, y1 till xn, yn. And then what you do is you feed it to the model, you train the model, then it will give you a hypothesis. Hypothesis will be H. Then you input some test data to get some prediction by test. In unsupervised learning, your data set only consists of X. which means you do not have the true output with you. In the earlier case, you had the true output, which is given an x1, output is y1, given an x2, output is y2, given an x3, output is y3, given an xn, output is yn. Here, you do not have access to your true output, and you still want to do some predictions with it. You might ask me how you can even think about something called unsupervised learning. Valid question. So let's look at it with an example. Let's say that you are a car manufacturer, okay, and you have surveyed two areas. Your survey was relating to people. You went and asked people that whether there is a consumer that prefers an electric vehicle or whether the consumer prefers a petrol vehicle. Let's say your results are this, which means if you look at area 1, the blue circles denote people have a preference for petrol vehicle, and the green circle denote that a person has a preference for a EV, electric vehicle. If you study the data that you have, and suppose that you want to build two manufacturing plants, you want to build one for petrol vehicles and you want to build one for EV. In which area will you place a electric vehicle plant, and in which area will you place a petrol vehicle plant? Can you answer given your data understanding of this one? See, I have not given you anything else. You went ahead and you have your data set contains only like EV, petrol, EV, petrol, EV, EV, and something like that. You do not have anything else. Okay. You plotted out this graph. Can you tell me which petrol in area 1, good, and EV in area 2, right? Why? How does the data tell you that? I have not given you the true output. See, I have not given you any other detail like why area 1 is better in petrol, why area 1 is maybe worse in EV, why area 2 is better in EV. I have not given you any other data. This is the data that you only have. Why do you think you will place a petrol vehicle in area 1? Why not in area 2? Okay, because you saw that in area 1 there are more people who prefer petrol vehicles. So maybe I will put the manufacturing plant for petrol vehicles in area 1, and for EV I will place in area 2. Very good. So maybe you have formed something called a cluster, and one of the famous algorithms here is K means clustering. Another example of unsupervised learning is, so you have seen in papers, uh, in newspapers, or in Google News, let's say there are news articles. Okay, there are news articles. Okay, I'll just speak out. Some news articles are related to politics, some news articles are related to sports, some news articles are related to movies, some news articles are related to general stuff. Google News, what it does is it sees a news article and puts it into the particular category. It sees an article is of sports, it will put it in the sports category. It will sees an article it is of the movies, it will put it in the movies category. It will see it's of politics, it will put it in the politics category. So it tries to form something called a cluster. Okay, a cluster where one cluster is of one group of news articles related to sports, one cluster is one news articles related to movies, and so on. So news categorization is another example of unsupervised learning. So okay, I've already talked about this. So if I ask you one small thing, okay, if you want to prepare for an exam, what are the steps that you will do? First is obviously you will learn the concepts, whatever it is, from any book or any lectures. Then you will practice your concepts that you learned using some PYQ, some previous year question papers or GATE, let's say. And then you will give the exam. Okay. In machine learning, the entire data is this one. There is something called test data that you do not have access to until you have built your model, which is you have prepared for the exam. Okay. So test data is this one. There is something called training data, which we have already talked about, which is you actually going and learning the concepts, and you actually trying to read the books or watch the lectures to learn the concepts. There is also something written here called validation data. Now think of it in a real life scenario. Why do you solve PYQ if you have lectures that teach you the concepts? If you have lectures that can teach you the concept, if you have books that can teach you the concept, why do you still go and solve the previous year question? What will you answer me? Why do you solve previous year question? Yes. According to you, what is the reason of solving previous year question? Yes. So you are saying that if I want to understand how the questions are asked, good, that's one valid point. But let's say you are learning your concepts. Okay? Now, if I ask you a very simple question, how can you be sure that one that you are doing, which is learning the concepts, can actually help you perform better in the test? How can you be sure? Or how can you give me an assurance that whatever concept I am learning today will help me perform good in the exam? If I study for the CAT, let's say I learn the concepts that are asked in the CAT exam, can I perform good in the GATE? How will you assure it before the exam? You are saying no, correct. But how will you assure it? Yeah, I have learned some concepts. I will tell you, I have learned some. I will lie to you that I have not. Actually, I have learned concepts of CAT, but I will not tell you this. I will say I have learned the concepts. You will tell me, okay, take this GATE 2018 paper and tell me how many can you solve. And I will tell you very proudly, my score is 0 out of 100. So, what is this that I have done? I have learned the concept, but I used something called a validation data, which is I went and solved GATE 2018 question to validate whether the model that I am learning, is it favorable for the test or not? You do not have access to the test data. You do not have access to the gate question paper during when you are learning, but you have access to the previous year data, previous year history question paper that you can use to validate whether you have learned the concept perfectly or not. Yes or no? Understood? Just learning the concept is not enough in gate, right? You also need to solve questions. What you are doing by solving it, you are trying to validating whether what you have learned is okay or not, right? Clear? So there could be a very important question here in the exam. Why do you need a validation set in your data? So I hope you understood why. Okay, fine. There are some more questions that I can ask you. Let us say that you have read only one subject out of all the subjects in the exam, in the GATE exam. What do you think? How will you perform in the exam? Okay. Okay, fine. That is a real life scenario that it depends on the number of questions are asked in the topic. Let's say there was only one question asked in the topic. So if I ask you this question that if you have read only one subject out of all subjects in the GATE, let's say during the exam, I told you that I have read only data structures, nothing else. Will you tell that, yeah, you are well prepared for the GATE? Will you tell me that? Let's say I prepared only data structure, nothing else. I don't know anything else. And I told you this thing. Will you tell that I am well prepared for the GATE? I have not read operating system, compute compiler design, TOC, COA, mathematics, aptitude, English, nothing. Data electronics, nothing. Discrete math, nothing. I just read data structure. So what is the problem here? Which according to the three types of data I discussed, the training data, validation data, and the test data, which data is less? The training data, right? If I read only one subject, then I only know concepts of that subject. So my training data is less. So can I say this that the more data you supply during training, the more data during training implies the better the model. So model, don't be confused, is nothing but just the hypothesis I was talking about. Can I say this statement? If I have more data during training, which means If I have data which is like notes of the second subject, lectures of the third subject, books of the fourth subject, can I say that my model will be better? I will be better prepared for the exam. So that is also that this is one of the most important questions, and I'm 100% sure this question will be asked. That is it true or false? The more data you provide, the better will be your model. Okay, is it true or false? So it's true, right? Second question is this. Let's say that you read all subjects of the gate. Okay, you have read all subjects that are present in the gate. You have learned the concepts, but you have mucked up all the PYQs, which means you just saw the PYQ, mucked up the question and the answer. How do you think you will perform in the exam in this case? You will certainly perform better than the previous case, which is you have read all the subjects. But does mugging up all the PYQs help you? You didn't understand any of the PYQs, okay? So you were not able to do what? Yeah, yeah, yeah. You have answers also, right? Access to it, PYQ. You saw, mugged up the question and then saw, oh, okay, the answer is this X. So yeah, fine. And in the exam, what you might think is, I will look at a question, I will look in my database, which is the mugged up questions I have. Look in the database if there is any question that I can see that I have or that was already there. If it is, then I will just answer it. Will you score good in the exam that way? Is it always true that whatever is asked in the previous years is the only thing asked in the subsequent year? No new questions are asked. Not always true, correct? So, which data do you think have I messed up here? The training data or the validation data? Training data is all good, right? You have read all the subjects. So, validation data is the problem here. When you're trying to validating your model, you are not able to do that in a very efficient manner. In the sense, you have mucked up the PYQ, right? So, that is not what GATE expects you to do, and that is not what will help you fetch the marks in the GATE exam. So what is the sweet spot? Which is the best model that you have? You have learned all the concepts, and by looking at the PYQ, you have understood how to solve let's say you have solved a PYQ question on um, data structure, let's say BST. With you understood the pattern how to solve, which is first, let's say the question that we solved some time earlier, which is the pre-order post-order. You kind of got an idea that if I have the pre-order traversal, first thing is I will construct the tree and then I will call the post-order. And how to construct the tree also you have known. So if next time if they ask any question that you are given just a pre-order, can you tell me the post-order? I can answer it. So what you are trying to do here is you are trying to generalize it. That in the near future, if there is any question on this topic, I can answer it. In the sense, if let's say there is a question on compiler design, let's say there is a question on what shall I say, or let's say there is a question on pipelining. Okay, there is a question on pipelining to calculate the CPI. Okay, if you know how to calculate the CPI once, you can know the pattern, you can do it a later as well. You can do for future questions as well. So the sweet spot is that the model that you have created, it should be able to generalize the data, entire data, as much as possible. Okay, this is the main point of this lecture of machine learning or any data science course. The model that you create, which is the hypothesis, it should be able to generalize the data you have as much as possible. Okay. Now, look at this data. This data denotes the amount of tension that a GATE aspirant takes some hours before the exam. X-axis denotes the hours before the exam, which means in the 0th hour, which is just before the exam, or let's say the 1 hour, 2 hour before the exam, you are having 120 units of tension, which is like the most amount of tension that one can have. And maybe 24, 25 hours, 24 hours before the exam, you have only 3 hours, 3 units of tension, which is a bit lesser. I will fit 3 models for you. You will have to tell me which one is the best one. This is the first model. This is the second model. This is the third model. Okay. So the 3 models. This is the third model. This is the second model. This is the first model. Which model do you think is the best? Which model among these 3 do you think is the best, according to you? This is the first one. This is the second one. This is the third one. So, if you understand carefully, let's look at each of the models. Let's look at the third model. Third model is like you are kind of missing the point here, which means you have fit your data, training data so beautifully that you are not able to generalize it properly for the test data, which means look at this point 78 here. Some other reason as well why you're taking tension. Someone comes and tells you that, hey, there's a new subject now in the GATE CS exam, which is software engineering, and then your tensions will be a bit more up. And there could be instances where later on someone might say and tell you that you know everything, everything possible, and then your tension level will be a bit lesser in that scenario. So, and if you look at the analogy I gave earlier, this is more like rote learning. You look at the lecture, you look at the book, you make notes, and you learn them by heart. You don't understand anything, you learn them by heart, and so your training data will be perfectly fit. This is called overfitting, and this is not what we want in an ML model, because this is not generalizing well to the test data. You just did rote learning where you didn't understand the pattern of the data. You just went ahead and learned whatever is there. This one, if you see, is not like you have learned everything possible, but this is more like you have not also generalized it very well, because it's a very basic model here. Because I could see that there is a polynomial fitting better here, but you ended up fitting something called a straight line. So this is called underfitting, which is your model is not very fit, very normal. So in underfitting, what you can do is you can change your h, which is your hypothesis function, from a line to a curve, and this one is called a perfect fit, or this one is called fitting, where you are able to generalize your model very well. See, you saw the pattern that there is a curve, and then you drew the curve, sorry, and then you drew the curve. And overfitting is more like you are doing something wrong, in the sense you are trying to overfit your data. Now, how do you curve overfitting? How do you curve underfitting? Mathematically, we will look at that in the mathematical section of the course. But these concepts that I have taught you today, if you understood it by analogies, then it will help you in the exam, because they will ask you questions on only these topics. Okay. So with this, maybe I will stop here, because I don't want to bog you down with too much details for now. We will gradually go step by step. Okay. This is the basic, very small plan that I have created of how we can cover. I'm not sure what we will cover, whether we can cover everything. We will look at the regression problem, the classification problem, naive Bayes classifier, which is based on the Bayes theorem, k nearest neighbor. So maybe I will start with these two first. So to start with these two, because these two are very simple. And third one is simple under the condition that you know the Bayes theorem. So my request will be to please practice the Bayes theorem before the next class. Okay. And decision trees is also there. Bias variance trade-off and cross-validation are two of the most important topics in this course. So there will be definitely questions from these two topics. Ridge regression is not a very important topic. You need to know what is regularization. That should be enough, but still we will try to see if we can do it. Logistic regression is also a very simple topic. It's not very difficult. Then we will move on to perceptron and ANN, or feed forward neural network. And then we end with unsupervised learning, which is k-means clustering. It's there only in your syllabus for now. So this is the rough plan of action that we are trying to maybe go about. And in the next lecture, we will look at what is a regression problem, what is a classification problem, and we will talk about k nearest neighbors. Okay, and then we'll move to naive Bayes classifiers and the other topics following that. I think I will be done. So these three will be done in one class, and naive Bayes classifier and some part of decision tree I can take another class. Bias variance and cross validation I will take two classes, because they are very important. No, sorry. Okay. So I will take 1 hour each for each of them. So one class should be enough for them both. And then if we get some time, then we will look into the ridge and logistic as well. Okay. Fine. So I hope you understood what is the basic crux of machine learning in today's lecture. I was not very sure how much you know about machine learning before, but still I tried to make sure that you have some basics done. And if you don't have any questions, maybe I'll end the lecture for now, for today, and we'll meet